So the topic is systems of linear and quadratic equations. Basically what we're trying to do is find the solution to the system of equations. When we graph these two, we'll see that it makes two shapes. One of these is going to be quadratic, so it'll be a U shape. Does it open up or down? Up. We know that because of the 2 in front of the x squared. So we can kind of visualize the shape on that, and then the y equals x plus 4. That's not a quadratic. What kind of graph would that be? It's linear. There's no squared in here. It's just x plus 4. And so that'll be a line. These two graphs are going to cross. The points that they cross are the solutions to the system. All right, so what we want to do on these is we want to graph the functions. Okay, so that's step 1. And 2 is identify where they cross, where they intersect. Okay, so we can do this mathematically by using substitution or elimination methods, but if you recall, that takes a while to do. It's very long and it's sometimes very drawn out. Now that we're using quadratics, that could be complicated. So we're going to choose to do the easier method. The easier method is to just graph them. We can use our graphing calculator, and with the tools in the calculator, we'll figure out where those two lines cross. All right, so does everybody have their graphing calculator? All right, so what I want you to do is go into the y equals editor and type in to the y equals editor 2x squared minus 5x plus 2. All right, so type that in for the y1. Yes? Yeah, you can just hit the x squared button. I choose to do the caret 2, but whatever you want to do is fine. All right, use the arrow, go down to y2, type in there x plus 4, x plus 4. All right, and so now that we have two graphs in there, our calculator will graph both of those. All right, so on the sheet that you have in front of you, the notes and examples, we've done the first step. The second step says to see the graph in a standard window, press the zoom button in the center beneath the screen, and then press 6 for zoom standard. So we're going to hit zoom, which is at the very top. And then option 6 is Z standard. So I'm going to hit 6. And what it'll do is it'll, okay, I have some other stuff in there. Right, the dots. I got to turn off my plots. So bear with me for a second here. All right. Go back to graph. Okay, so there we go. So now does mine look like yours? Okay, everybody good? All right, so we've graphed the quadratic is the U shape, and then the linear equation is the line. All right, let's start with the point of intersection farthest to the left. Estimate what the x value would be for the ordered pair. In this case, it looks to be about negative 0.5. So what we're trying to do is figure out where our line intersects the quadratic. Okay, so we're trying to find that point right there. And we know it's about negative 0.5. So now we're going to hit the second and then trace button. Second trace, and we're going to go into the calculate menu. Once you're in the calculate menu, choose option 5 for intersection. Okay, it should look like that. And it's asking, okay, if you flip it over, it prompts you, when you see this equation, it's prompting first curve. Notice that the equation at the top is 2x squared minus 5x plus 2. So is that your first curve? Yes, it is. So hit enter for yes. Now it's prompting for the second curve. Notice the equation at the top is y equals x plus 4. Is that the second curve? Yes, it is. Does it matter what order it gives you first and second curve? No, it doesn't. But if you had 10 equations written into your y equals editor, you want to make sure it specifies which is the correct one. So maybe in the future you might have more equations and you only want to find the intersection between two certain equations. That's why it's doing that. So you hit enter again. All right, now this part where it prompts you for a guess. The calculator wants to know roughly what your guess is on that. And this is a way to tell the calculator that you want the intersection that's on the left, not the intersection that's on the right. So if you give it a guess that's in the ballpark, it'll find the intersection for you close to where your guess was. All right, so let's type in there negative 0.5 for our guess and hit enter. It's thinking, and voila, there's our intersection. This system, these two equations intersect at x equals negative 0.3027 with some more digits, and then y equals 3.69. So was our guess right? Guess negative 0.5? No, our guess was not right. The calculator told us it was negative 0.3, but we were close. Any questions on that part? All right, so I'm going to go back to the worksheet now and write in that ordered pair. So one of the intersections is at negative 0.3, comma, whoops, 3.69. I'll just round it to 3.7. All right, that's one of my intersection points. See if you can go back and whoops, find the intersection for the other point. All right, we want to find this point up here where my arrow is pointing. All right, so use the same steps and try to find the other intersection point, because notice that there's two intersection points. So go back to your calculate menu, go back to intersect, it's asking for first and second curve, but this time put in, what would you put in as a guess? Yeah. Where do you think it intersects on the other side? Right there. Around 4. So type in there 4 for your guess. Hit enter. And there you go. All right. Isn't that easier than doing upper bound, lower bound like we were doing before? Okay. So now our other intersection point is 3.3 and 7.3. Okay. So those are the two intersection points of our system. So how many answers are there for this problem? There's two answers. Here's answer number 1, answer number 2. So your first intersection point is the ordered pair negative 0.3 and 3.7. Your second intersection is 3.3, 7.3. All right, go ahead and try example. Was that example? Example 2 is what we just did, right? Oh, find the other solution. We just did that one. All right, now go ahead and try example 3. Find both solutions to the system. Now, if it's not written in y equals mx plus b form, you've got to solve for y first. Then you can type it into the calculator. All right, so we're looking at example 3. And we noticed that the two equations were y equals x squared minus x minus 2. And the other one was x plus y equals 2. Well, I converted the x plus y equals 2 into y equals mx plus b form. So it should say y equals negative x plus 2, and that's what we type into our graphing calculator. All right, so I'm going back to the y equals editor. I'm just going to clear out my other two graphs and type in there, let's see here, x squared minus x minus 2. That's one of them. The other one is negative x plus 2. Negative x plus 2. Make sure you don't type in there minus x plus 2. Calculator doesn't understand that. All right, so I'm going to zoom standard. So I'm going to do I'm going to do zoom and then hit 6. So there's my graphs. So I see the U shape and then I see the line. So we're looking at a quadratic and a linear, trying to identify where they cross. What do I do next? Second, trace, which is the calculate menu. I want to calculate an intersection, which is 5. Is this my first curve? Enter for yes. Is that my second curve? Enter for yes. What's my guess? Let's try the left intersection side. -1, -2. Okay, so I'll type in there -2. Okay, I'm guessing -2 on this one. All right, and I was right. The intersection was -2 and 4. -2 and 4, so I'll write that down. That's one answer. All right, and to do my other intersection, I'm going to go back into my calculate menu, choose 5 for intersection, first curve, second curve. Where does it intersect on the right? Somewhere around +2? Hit 2 for my guess, and I'm right on that one, 2 and 2, 0. 2, 0. Okay, so that's the second answer. Now, what would be a way to check these if I wanted to see if these were correct? Because you can't always trust the calculator. You can't always trust it. What's that? Separate them? If I put a 2 in for x in any of these equations, and I should get a 0 for y. Okay, so try this one. If I put a 2 right here, is -2 plus 2 equal to 0? Yeah, it works in there. Up here, if I put 2's in for the x's, and then as I solve this, I should get a y equal to 0. 2 squared is 4, minus 2 is 2, minus another 2 is 0. So it works in both. Okay, so that's a way to check it. And I can check this one as well. I can put -2 and see if it comes out to be a 4. All right, so there's a way to check these. And by the way, if you get a multiple choice question on your test, it might be easier just to take one of the multiple choice answers and plug in those numbers and see if it works. Raise your hand if you used that strategy yesterday instead of actually solving the system. You just kind of took the multiple choice answers and plugged them in to see if they worked. If they didn't work out right, it was not right. If they did work, it was your answer. So we'll look at some more strategies like that later. Go ahead and